Hi, I'm Jason. Welcome back for part 2 in my series on controlling an EMCO Compact 5 PC lathe with LinuxCNC and Fusion. Now, we proved in the last video that we at least had the lathe moving in the right directions, but we need to be a lot more accurate than that. And the scaling settings that I found in the initial configuration that I downloaded were wrong for my lathe, so it's well worth you checking as well. First, I'll test with a rule to make sure we're somewhere close so I don't destroy my dial gauge. Now, I measure the distance from a reference point, in this case the face of the chuck, to just the edge of the cross slide there will do, so that's 70 millimeters in this case. Okay, so now if we start up the lathe, and in LinuxCNC, I'll select the Z-axis, and rather than continuous, let's go for 5 millimeters. So I'll just go +5, and another +5, and turn him off now. And now if we go in and check, you can see that's 80 millimeters, so that's looking like we're correct there. So now it should be safe to test on the dial gauge. So let's just move that back into range of the camera. So I'll take Z back to continuous. I'm using a dial gauge here, but you can use feeler gauges, gauge blocks, or anything that you can accurately measure the gap between your tool post, or your cross slide and a reference surface like the chuck. Now, the disadvantage of using the dial gauge is that you need to get it perfectly parallel to the movement that you're measuring for the best accuracy, and the easiest way to do that is to 3D print a holder for it, but my 3D printer is out of action at the moment, so I'm just going to eyeball it for the sake of this demonstration. So I've locked the base onto the ways here because they're the most stable reference. So again, we'll get it all started up, and let's jog a few millimeters towards the dial gauge. So I'll change this back to 1 millimeters, and let's go a millimeter at a time. And that is looking pretty good to me. Back again. Okay, so it looks like we have our scaling correct. Now that can be affected by the number of steps per revolution of your stepper motor. In this case, the default stepper motors that you get with the lathe are 72 steps per rotation. But as I mentioned earlier, the config that I downloaded was different to that, so it's well worthwhile you checking. The dial gauge is set up to test the X-axis now, so let's start it all up again. Switch to the X-axis and try the same. And again, that's looking perfect. If you're going to use more than one tool in your projects, then you're going to need to tell LinuxCNC where the cutting edge is on each of your tools. You can store the details of up to 1,000 tools, and I've included a spreadsheet in the configuration download on GitHub. It's tools.ods. Have a look for it in the root directory. It's an open document format file, so you can open it in Excel. If you look at the contents of that spreadsheet, you'll see that I've listed 4 of my tools. This is what they look like here. The part numbers on the insert holders follow an ISO standard for metric tool holders, and you can decipher them with the help of a chart like this one. You'll find it at the link below. From that decoder, you can see that my first tool, an SCL CR1010E06, is a screw lock for the first S, 80-degree diamond insert for the C. It is an edge angle offset shank with -5 degrees cutting angle. It has 7 degrees clearance for the carbide insert, and it is a right-hand tool. The second part of the code, we can see that it is a 10mm square shank. It is 70mm long for the E, and it takes a 6mm cutting edge insert. So with that code, I then found the drawings of the tool holder geometries and their inserts, and I've inserted those into this table. From those, we can work out the relative position of each cutting face. So I'll open up the drawings for the first tool, which we find here. Now I've chosen to use the right-hand face of the tool holder as the reference. So for this particular tool holder, you can see that the cutting face is minus 12mm from that reference face, and that's because towards the chuck is negative in the z-axis. So I've recorded that in the spreadsheet as minus 12 for the z offset. The orientation is the tool orientation relative to the lathe. Now, the orientation values are listed at the URL below, and I'll just show those. So in this case, our orientation is position 2. The front and back angle are measured clockwise relative to the z-axis. So our front angle is 85 degrees and our back angle is 5 degrees. Now I've also included the tip radius in there. That information we need to get from the geometry of the carbide tip. So if we go back in here and we look at the tip for that particular tool holder, and we can see from the drawing here, R0.2, so it's 0.2mm radius. And so I've entered 0.2 in the table as well. Now I only have 2 quick change tool post adapters, so I'll only walk through the setup for 2 tool holders. The second tool holder that I'm going to configure is my parting tool. So this is the actual one that I bought here. But you can see that the drawing doesn't tell us the Z offset, and I couldn't find it in any other drawing either. The closest that I could find was in these drawings here, which shows that the smaller tool holders have an offset of 0.25mm beyond the far side. So we'll just go with 0.25. Now I'm going to choose the right-hand cutting face on this parting and grooving tool as my reference, because that's the relevant one when I'm parting. So that's going to be minus 8.25mm from the reference face. Now the orientation for this particular tool is position 6, and the front and back angles are both 90 degrees. So that's our 2 Z offsets covered. We could also measure the X offsets, but there's no good reference face on these tool post adapters. So we'll touch off on the lathe to set those. So now we just need to feed this data into LinuxCNC. In the File menu, you'll find Edit Tool Data. So fill in your data, leaving the POC, the pocket number, the same as the tool number. Now note the change in sign in the Z column. So we had negative values, but in this table, we need to convert that to positive values. So save that file and quit. Now to check what that has done, we need to tell LinuxCNC which tool holder is loaded. First we'll home the Z axis to make the maths easier. Now we don't need the lathe turned on for this, we'll just be working in LinuxCNC. So on the manual control tab, we need to turn it on first. Select the Z axis and click on Home Axis button. So note that our Z coordinate on the screen here is now 0. I'll also zoom in on the tooltip to make it a little bit easier to see what's going on. Now on the MDI tab, type the command T1 M6 G43. So it asks us to insert our tool 1. So that's told LinuxCNC that we are going to use tool 1. We're going to change it manually, the M6, and that we want to load the offsets from the tool table. So you can see in the status bar down the bottom that the LinuxCNC knows that tool 1's now loaded. Now the tool tip is the wrong shape though, and I've yet to work out why. So if you want to have a look at tool 3 later, you'll see that that one actually draws the shape properly. More importantly though, the cutting face has moved 12 millimeters to the left, which is the value from our tool table. Now if we change tool holders again by typing T4 M6 G43, you can see that the cutting face has moved to the right, as you'd expect, and by 3.75 millimeters. So it looks like our Z offsets are okay. As I mentioned earlier, we could do the same for the X-axis, but there is no machine face on these tool adapters that I can use as a reference. So if yours do, then feel free to go ahead, but you will still need to do this next step just to confirm its accuracy. So first we'll home the axes. This sets the machine home, so it's the position of the tool relative to the rest of the lathe. It's also called the G53 coordinate system. Now one annoying thing about this particular lathe is that it doesn't have any limit switches. So it is possible to drive the carriage to the physical stops, and at that point the stepper motor continues to spin, but the clutch slips. Now that's a very bad thing if you are in the middle of a job, because then LinuxCNC loses track of exactly where the tool is. So it thinks it's driven it further out than it actually has, and so when it drives it back in again, it's going to crash into your job. So we'll drive it to a safe home position that's short of those mechanical stops, and we will tell LinuxCNC to remember that position. We'll home the X-axis first. So grab one of your tool holders or just some other straight edge, and I'm just going to sit it against the back edge of the crossfeed stepper heatsink and drive the crossfeed out until it just touches it. So we're set for X there, and let's go positive X. Getting close now, so I'll just wind the speed back a bit. Let's just touch that now. So that is going to be our X home position. So we can click the home axis button, and you can see we get the little marker on the X. And note also that the radius and diameter have also gone to 0 on the display here. So now we're going to drive the carriage towards the chuck until it's just a few millimeters short of the end of the ways. So we'll switch to Z, and we'll stop about 3 millimeters before it hits that hard stop. Now I have my leftmost protruding tool in there at the moment, just to make sure that it's not going to foul on the chuck. Now if yours will, if you have set up a different tool holder that is going to foul, then pick another spot for your Z home position. It doesn't matter where it is, it's an arbitrary thing. Okay, so we'll home our axis there as well. And you can see the Z now has the homed mark, and it's gone to 0 as well. Okay, so I'll just reset our live plot, move all the lines from that. Okay, now if we jog the carriage away from where it is, let's wind it up a bit. And some X. Okay, and now check you have a clear line back to that home position, which we do have there. And now go to the MDI tab. and type in G53, G0, X0, Z0. So that means move rapidly, that's the G0, in a straight line to the machine home position, which is the G53, and that home position is X0, Z0. So as always, hand on the E-stop just in case, and we'll click on the go. So you can also use this command just for a single axis, because often a G53, G0, X0 is enough to get the carriage out of your way for whatever you need to do. So with the machine coordinates sorted, we'll start working on a workpiece. Now machine coordinates aren't particularly useful to us now, so we'll use a different coordinate space, G54. So this applies an offset to the machine home, so that you can have a different home position that's relevant for each job that you do. Now generally, the workpiece home will be the axis of rotation of the lathe for the X, and the tailstock face of the workpiece. So basically about that point there. So here's what it's going to look like on this lathe. To set the X workpiece home, we'll turn a cylinder and measure its diameter. So first, make sure we have the right tool. So on the MDI tab, we'll rerun the T1 M6 G43 command. Now I'm just going to be jogging the lathe to make these cuts. So first I'll line up the cutting face and then drop the jog speed down to something sensible to actually make the cuts. So back to manual control, and let's move out this way a bit. Okay, just starting to take a little bit of the surface off there. So let's wind the Z out a little bit. Give it some lubrication. And again, leaving the shield off for the sake of the video, but I'll stand well clear. check that. That's looking good. So first I'll jog the tool out of the way, but because I'm setting the X home position, I need to move it only in the Z direction. Turn the lathe off and clean that up. And that looks like 24.67. So we're going to touch off and 24.67 and OK. Now I've just touched off on the wrong axis. Fortunately, that's not going to break things for us. So we'll go back to the X-axis now and we'll touch off 24.67. And you can see now we have a diameter of 24.67 reflected in the coordinate display. Now if we open up the tool table, so I'll go File, Edit Tool Data, you'll see that nothing's changed. So because we were just touching off, we haven't changed any relative measurements. So we're going to use this particular tool 1. This is going to be our reference. So we didn't want to put anything there. It's actually, in actual fact, it's 0. So we'll just put it in 0 there, just to make it clear. Now I'll turn the lathe back on and jump back into the MDI window. And this time I'm going to type G0 X0. Now there's nothing between the tool and the axis of the lathe, so I should be able to safely do that. But again, hand on the E-stop and go. Okay, and now if I bring up the tailstock, that should be bang on dead center. So the G0 command uses the G54 workpiece coordinates by default, but be very careful when using it because G0 X0 Z0 and G53 G0 X0 Z0 go to different places. One's going to try to drive the tool into the center of your workpiece, while the other's going to drive it through your workpiece if it gets in the way. I'll just turn that back off again while I use some poor man's blue. Back on so I don't forget. And now we'll change tools. So we'll go T4 M6 G43. Okay, let's take our tool off. Swap it for tool 4, our parting tool. Okay, now let's bring the cutting edge up close. So back to manual, and let's start by going G0 X 24.67, wasn't it? And you can see, if I jog that back up to the face, that is nowhere near where we want it to be because of the difference in tool lengths or tool protrusions. So let's jog it out further. Wind our speed down a bit. Just take that off. Get a spin, just do a little bit of gap there. Okay. Let's sneak up on that. So that's the spot just there. Now that we have the cutting edge of both those tools in the same position on the x-axis, we can use the tool touch off and making sure that we have the x-axis 24.67 and OK. And now if we check the tool table, you'll see that we have an x offset of 12.26 millimeters. Now I've deleted my X offsets from the file in the download because even if we do have the same tool holders, your X offsets will be different because it just depends on exactly where you mount them in the tool adapters. So let's check now just to make sure that's all okay. So I'll turn that back on. And we'll drive that a little further away. From the workpiece. And let's go back to the MDI tab. And we'll go G0X0. Which should take it into center. So it looks pretty good. And now if I do a tool change, let's change back to tool 1. And run the same command. That's looking spot on. Now you'll need to follow the same process to set the X offsets for the rest of your tools, and just remember that if you move any of your tools in their tool adapter, then you will need to update the X offset. Now we should also check our Z offsets, so let's go back to tool 1 as we are there, and we'll face our workpiece. So first I'll jog in close. a little bit of clearance there, and let's go Z.1. Okay, and some lubricant. Rotation on. X. And that looks perfect. Okay, let's move the tool right out of the way. So we'll do a G53, G0, X0. Okay, just turn that off so I can clean it up. Okay, face looks good. So this time, because we already have offsets in there, we're just going to touch off. So touch off, and cancel. We want the Z axis this time. So we're touching off on the Z axis and we are at 0, so okay. And notice we have this line here from the home marker, G54, that points to where the workpiece 0 is. Now, we'll blue our face again. And I will jog. Oh, sorry, first I'll change tools. So we'll go for T4 this time. Make sure it's all clean so it sits at the right height. And continue. Now let's see how close we are with our initial values. So let's send it to Z0 with G0, Z0. Making sure we turn it on first, otherwise we mess everything up. And I'll just jog that in a bit closer so you can see. And you can see that the right hand edge lines up, which is what we'd expect because our reference is that right hand corner of the parting and grooving tool. So we need to go to X2 to be in a better position. So let's move up to X2 instead. Oh, sorry, Z2. Now if I just jog that in, actually let's go Z. We'll move it 0.05 further. And then the X. We'll jog in. And we're not touching there now. So let's ease into it. Just starting to score there now. So now that we're there, let's go back to the Z axis and we'll do the tool touch off. And remembering that we are 2 millimeters because that's the thickness of our insert. And let's look at how that has changed the tool table. So you can see we're 7.86, whereas we were 8.25 before, so a little bit out there. So with that, our lathe is now ready to take an NC file and start doing things automatically. So I'll cover that in the next video. But there's one last tip for this one. Before you shut down CNC, send your carriage back to machine home. So just make sure we've got clearance there. We can go back to NDI, and the safest way is G53, G0, X0. Take it out in the X direction first, and then G53, G0, Z0. Now the reason for doing that is that when you next start up, you just need to hit the home button for each axis and then set your Z workpiece home and you're good to go. Otherwise, you're going to have to go through that whole process of setting the X workpiece home every time. Thanks for watching, everybody. Now in the next video, I'll cover how to set up AutoDesk Fusion so that it knows your tooling as well, and then it can generate the NC files for you and we'll turn something.